Think we are up and running. All right, hi students. Today we are going to learn about the conservation of matter. So this kind of goes off on what we've been learning about physical and chemical changes. When we have a chemical reaction, there's this law that takes into place that states that you can't create or destroy matter during a chemical reaction. So we've touched a little bit about what that means, but what does it really mean in terms of our chemical reactions? Before we dive into that, we really need to understand how chemical equations or chemical formulas are made of. So we have what's called a chemical formula. Let me just move my face out of here so you guys can see this a little bit better. Okay. So a chemical formula is really just how we manage to talk about our chemical reactions. And the chemical formula just tells us what elements are involved and how many of each there are. Now, we're going to get way into this when we get into the periodic table, the next unit. But as a preview, just so we can understand how our reactions are happening, we'll start with our basic water. Everybody knows water is really H2O. You hear it all the time. But what does that really mean? Well, H2O, the chemical formula for water, tells us exactly what elements are involved and how many of each. For example, H stands for hydrogen and O stands for oxygen. So we now know that water is made out of hydrogen and oxygen. But then we also have this 2. This 2 goes along with the H. So if the number comes after the letter, it tells us that there are actually 2 atoms of hydrogen in our H2O molecule. If there's no number behind it, like there's none here, that just means there's 1. We don't need to write it. It's understood. Okay? Now, the reason why I'm telling you about the chemical formulas is because sometimes you might see a chemical reaction when we're asking you to find out about the law. You might see it in the chemical formula representation, like this. So here I have, sorry, let me move my face out of the way. There we go. So here we have a chemical reaction of making water. This arrow is really called yields, but we're going to pretend it's like an equal sign, like math class. And we have 2 parts of our equation. The first part, or all the stuff to the left of this equal arrow, these are called our reactants. In other words, what we start with. So in our formula of making water, we have to start with 4 parts hydrogen. I know that there's 4 parts because 2 and 2 is 4. But I also start with 2 parts of oxygen. Those are what I call reactants. Those are going to react to produce water. Which brings us to the right side of the arrow. Everything on the right side of our equal arrow, these are called products. In other words, what we produce or what we end up with. So since I'm starting with 4 parts hydrogen and 2 parts oxygen as my reactants, they're going to equal or produce 2 parts of water, 2 molecules of H2O. Now, if the letters and numbers are a little confusing, we can also use colored dots. Here's the same reaction, just now in pictures, and I like pictures. So here we have 4 parts of hydrogen. There's hydrogen, 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 and hydrogen. They're all represented by a blue dot. They are still in the reactants. I'm adding to 2 parts of oxygen. These are represented by the red dots. When we react these together, they're going to produce water. And because we have 4 hydrogens and 2 oxygens, they actually make 2 parts of water, which is why we have 2 molecules here. But notice, I still have 4 blue dots and 2 red dots on both sides of the reaction. And that's where our law of conservation of matter comes in. Remember, the law says we can't destroy or create matter. What we end up with has to equal what we start with. And that's the whole idea of setting up these equations with our reactants on one side and our products on the other, so we can make sure that what we do end up with does actually equal what we start with. So let's do a little bit of a refresher. Here we have our law of conservation of matter, what the law actually states. Again, let me move my face just a little bit up here to the corner. Okay. So again, this law states that matter and mass can't be created or destroyed. It can only be changed from one part to another. So what this means is whatever we produce or whatever we react has to be the same as what we started with. For example, if I have 30 kilograms of logs that I want to burn, I'm going to add fire, which is roughly 1 kilogram. It's not that much mass. 30 plus 1, that's 31. That's how much total reactants that I have. But when I burn it, it's no longer logs and fire anymore. It's now a giant pile of ash. Now, that ash might have been reduced in mass just a little bit. For example, this ends up with 28 kilograms of ash, but we also produced smoke. Now, this is where the hard part comes in. If we don't capture that smoke, like in a balloon or in a closed balloon or something like that, we're not going to know how much that weighs because gases are invisible to us and they spread out really fast. So, in order to make sure that we didn't really destroy any matter, we have to catch that smoke. So, this case, my ashes might be 28 kilograms only, but I also had 3 kilograms of smoke that maybe got released to the environment. But if you still add 28 plus 3, you still get 31. That's because we cannot destroy or create matter. What we end up with has to equal what we started with. And that's the whole idea behind this law of conservation of matter. But let's do it with dots, colored dots. My second picture, I've got 4 blue dots and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 white dots. 12 white dots and 4 blue dots. They're going to go into a reaction. They're going to change. They're going to do its thing. But you'll notice that even when they look different, we still have 4 blue dots and 12 white dots. We didn't create or destroy any of them. We just made them look different. We rearranged them. And that's the idea behind this law. Here's another example of our water molecules. Again, we have 4 hydrogens, which are yellow, and 2 oxygens, the blue ones. They're going to react and create water. But you'll notice that I still have 4 yellows and 2 blues. They're just rearranged a little bit differently because we can't create or destroy our matter. Whatever we end up with, our products, has to equal what we started with, our reactants. So it really doesn't matter if I have a piece of paper and I take the mass of this, and let's say it's 5. And then if I rip it, and I take all my pieces, I'm throwing it on the floor. But if I take all of these and take the mass of this, it's still 5. That's because I didn't create or destroy it. I might have ripped it, so we might think it's destroyed, but the mass is the same. And that's the important part of the law of conservation of matter. You can't create it, you can't destroy it, we can only change it. What you end with has to equal what you started with. And that is a wrap for the law of conservation of matter. Thank you for joining me today.